Hi guys, today we're going to be talking about linearization. Sorry for the really bad posts. I've been really caught up with my tutoring job, and so I haven't had time to make these videos, also with my college apps going out. It's been pretty difficult, but I'm going to try to post more, as I always say. But yeah, so today we're going to be talking about linearization, and that's basically when you are given a very odd number and you're trying to find its output. So, for example, here we have, given that f has a linear function, f of 3 is equal to 9.8, and the f prime of x, so the derivative of x, is 2. So, when we're going from 3 to 4, you're increasing your x value by 1, and if your slope is 2 over 1, you're basically moving up 2 and to the right 1. So, when we're looking at y values, if your first y value is 9.8, let's just plot this real quick. If your first y value is 3, and then let's just say this is 9.8 right here. There's your first value. If your slope is 2, it's going to go up 2 and to the right 1. So your new point is going to be right here. When you're looking at f of 4, you're going to be moving up 2 y values. So if we started at 9.8, we're going to add 2, and we're going to make it all the way up to 11.8. Now, this is a little bit more difficult. We are given a value like 3.4 or 2.5 or 2.8. What we're going to want to do is we're going to want to add each component individually. So we have two pieces here. We have f of 3 plus f of 0.4. And that makes it a little bit simpler here. We already know that f of 3 is 9.8. And then we're going to add that to 0.4 times your slope, because that is how much y value it is going to cover when the x value moves 0.4. So all I did was I did 9.8 plus the 0.4 times 2, which is the slope. And when you add that together, you get a 10.6. For this one right here, you have f 2.8. Very similar, but you could technically do f of 2, which would be 9.8 minus 2, and then add 0.8. But personally, I find it easier to already have your 3, and then you minus the 0.2. So we have 9.8 minus, and then if you do 3 minus 2.8, you get 0.2. So you do 0.2 times your slope. And when you add that all together, or you do 9.8 minus that, then you get 9.4. So that's pretty easy. That's not the whole main part of this lesson. The main part of this lesson is being able to estimate nearby function values. So we are given a f of x, usually, and we're asked to estimate a certain number. So if you look at this here, we have estimate your root 4.1. If we look back at the function is root x, so we know that x is equal to 4.1. But like we did here, we're going to try to pick the nearest or closest whole value that kind of works easily in the function. And for this one, it would be 4 because it's very close to 4.1, and the square root of 4 is 2. Not a weird number. So we're using 4. We get x is equal to 4, and then all we're going to do is we're going to plug in the 4 to our original value to get the y value. So if we do root of 4, we get 2. So our function has a 0.42 on it. Next, we're going to find the derivative. Now, we have root of x, and technically this is a exponent in a fraction. So you have x to the 1/2, if you see here. So if you divide that out, you get 1/2, or if you apply the power rule, you get 1/2 x, and then 1/2 minus 1 is negative 1/2. So basically, when you put that all together, your final result is 1 over 2, and then you have your root x due to the negative 1/2. Okay, so there's your final f prime value. Now we're going to write an equation. So we have your y value and your x value. we're going to put this in point slope form. We have y minus 2, which is your y value, equals your slope, 1/4, which is what we determined when we plugged in 4, which is your x value, into our f prime, and then you get 1/4. Then you have x minus 4, so your 4 is your x value, and that's basically how you do a point slope form equation. This one we're not going to put into points or into slope intercept form. We're actually just going to bring the 2 over to the other side. And we are going to replace the x with our starting value of x, which would be 4.1. So we have y equals 1/4 times 4.1 minus 4 plus 2. When we factor this out, I usually typically like to put the 0.1 or whatever the value is into fraction form. So we get 1/10. And then we have 1/4 times 1/10 plus 2. And when you add that all up together, you get 81/40, or 2.025. So that is basically saying when you plug in 4.1 into your root of x, you're going to get a value of around 2.025. Same thing here. If you would like to pause the video and do this question, you can. I'm actually going to scroll up for you guys. Use the same f of x, and then you can solve it, and then you can check your answers with this. Perfect. Now we're going to do a little bit of a difficulter example here. So we have f of x is equal to x squared plus 3. First is to find the derivative of this, and also, sorry, we're trying to find the f of 1.2. So your 1.2 is your x value. Okay, so in this previous example, we were given the full function, so we were given that where we want to find what 4.1 is. In this one, we're just given that we want to find when x is 1.2 what the f of x value is. So basically, we have 1.2 here, and then we're going to first start by taking the f prime of x, which is your derivative, and we're going to pick a value closest to 1.2. So we got 1 for the f of 1, or f of x value, and then if you plug the 1 into the f of x equation, then we get 1 squared, which is 1, plus 3 is 4, and the root of 4 is 2. So you get 1, 2. To find the derivative, we're going to use something called we're going to use the chain rule, I think, because we have a function inside of a function. So we have the root of x squared plus 3. If you have your a is going to be equal to your root x. Your a prime is going to be equal. If you don't know how to do these rules, please go back and watch a video on how to do this. But your a prime is going to be 1 over 2 root x. Your b is going to be equal to x squared plus 3, and then your b prime is going to be 2x. When we put in the chain rule formula, we have 1 over 2 root x squared plus 3, and then times 2x. Now, if we put the 2x on the top, then we're actually going to be simplifying this. We can cancel out the 2's here, and we get x over root x squared plus 3. Perfect. So now we're going to plug in the x value that we estimated, which is 1, into our f prime of x, just like we did before. So we get 1 over 1 squared, which is 1, plus 3 is 4, root 4 is 2. So you get 1 over 2 as your f prime. Now let's make our equation. Pretty simple again. It's going to be your y minus your y value, so minus 2, is equal to your slope, 1/2, times your x minus your x value, which is 1. Move the 2 over to the other side and substitute your real x value in for x. Y equals 1/2 times 1.2 minus 1 plus 2. Now we're going to simplify this out. So if you do 12, I distributed the 1/2, by the way, and then I added the 2, which is your 40 over 20. So you get 12 over 20 minus 10 over 20 plus 40 over 20. And that should equal to 42 over 20, which is equal to 21 over 10, or 2.1. That is your lesson on linearization. If you have any questions, let me know in the comments. Bye!